Okay, so factoring perfect trinomials, it's just the same as the last ones that we were doing, except now the answer is just written differently. So I'm just going to start with why it's written differently. So for example, if I have 4 times 4, I can really just write that is 4 squared. That's the same thing, because 4 times 4 is 16 and 4 squared is 16. So you can just write it like that. If I have x times x, well, since it's x times x, it could just be x squared. So really, it's something is just a square or a perfect square if the number times itself is a square. So then it's just going to be x squared. Okay, so something times itself just makes it squared. So if I had something like this, x plus 1 times x plus 1, well then that would just be x plus 1 squared. Okay, so factoring, if they're perfect squares, you're just going to end up getting the same thing here and there, and then you can just write it like that, and that's your answer. Okay, so let me do an example. So if we have x squared plus 10x plus 25, we're just going to do 1 times 25 is 25. Two numbers that multiply to get 25 and add up to get 10 are 5 and 5. So then over here I'm just going to write x plus 5 and x plus 5. And since it's the same thing here and the same thing here, I'm just going to have x squared. Whoops, whoa, sorry. Oh, don't do that. It's going to be x plus 5 squared. And that's your answer. So a square can't distribute. Just so you know, a lot of students get that mixed up. So you can't like just say x squared plus 25. That's not true, because really, if we were to go backwards, this is just really meaning x plus 5 times x plus 5, which we know that if we were to FOIL that out, we would come back to our answer. So just so you know that you cannot distribute a square. Okay, let's do another one. Sorry, I'm just figuring one out really quick. Okay, so okay, so the first thing we're going to do is see if there's a GCF. So 4, 12, and 9. No number can come out of 4, 12, and 9. So then I'm going to do 4 times 9 is 36. Two numbers that multiply to get 36 and add up to get negative 12. Sorry, I'm running out of room. Is going to be negative 6 and negative 6. So then I'm going to have 4x, and then the numbers that worked were negative 6 and negative 6. Now we're not done yet. These aren't perfect squares yet because they can both go down. So now this I can divide by 2, same with this one. Now just because everything divided by 2 doesn't mean I can move it out to the front. The only time that something moves out to the front is if in the very beginning 2 can go into all of those, which is not true. Okay, so let's divide 2. So 2x minus 3 and 2x minus 3, which you can see we have the same thing here and the same thing here. So it's going to be 2x minus 3 and then squared. And that's our answer. Okay, I just want to talk about the difference of perfect squares now. So that was factoring perfect squares. Now let's do difference of perfect squares. Oh, you ran out of toys. Here's another one. Look. Okay, so let's try x squared minus 25. Okay, now this is called difference of perfect squares because it's a perfect square, because x times x is a perfect square, and 25 is a perfect square because it's 5 times 5. So difference means minus. So difference of perfect squares. Now this, you really could write this as this, which just says, hey, what are two numbers that multiply to get negative 25 and add up to get 0? So those two numbers would be negative 5 and positive 5. So then over here we would have x plus 5 and x minus 5. So just when there's nothing in the middle, you can just rewrite it and say 0x. So what multiplies to get that and adds up to get 0. But I just wanted to do one of these because this right here is not perfect squares. Because in order to write it as it squared, it has to be exactly the same. But you can see that on this one, it's +5 and -5. So then that's our answer. Okay, let's just do one more difference of perfect squares. Let's do 4x squared minus 9. Okay, so for this one, we have nothing in the middle because there's nothing attached to just an x, so I'm going to rewrite it. 4x squared. Oh, and actually first, before you do that, we should check if there's a GCF. So is there a number that can come out of 4 and 9? Nope. So then I'll go on to the next one. Okay, so plus 0x minus 9. Okay, so 4 times -9 is -36. Two numbers that multiply to get -36 and add up to get 0. It's going to be -6 and +6. I'm handing her toys and she's just throwing them off of her tray. There's Sam. There you go. Yeah, there's something to play with. Okay, and then we're going to go back over here. So 4x minus 6 and then 4x plus 6. Both of which can be divided by 2. And I'm not going to take the 2 out because it didn't come out at the very beginning. So it just goes away. So 2x minus 3, 2x plus 3, and I cannot rewrite them as the same thing squared because one's minus and one's plus. Okay, hopefully that answers your questions. Let me know if you have any more.